PaLM 2 is about AI everywhere, all at once. We will look at some details in the PaLM 2 technical mind. To me, PaLM 2 is about how do you make AI ubiquitous. It is not about this. It is about compact, performant, task-optimized LLMs. But of course you want to know, well, how does PaLM 2 compare with GPT-4? Let us look. First, let me say that GPT 3.5 is probably larger than PaLM 2. I will tell you a little later why I think so. The first hunch is because it's extremely fast. We look at the first benchmark, the MMLU. Here, GPT-4 on the left has a score of 86.4 for 5 shot. On the right, PaLM 2 has 81.2 for the same 5 shot. So clearly, this is a win for GPT-4. GPT 3.5 on the other hand has a score of 70%. So PaLM 2 clearly is better than GPT 3.5 on this test of logic. On HelloSwag, GPT-4 scores 95.3, PaLM 2L scores 86.8 on the one shot. This is a little hard to compare, but I would say that the one shot would probably be a better performance. On the ARC reasoning challenge, GPT-4 scores 96.3 for 25 shot. PaLM 2 on the other hand scores 95.1 without using 25 shot, but it uses self-consistency and chain of thought. GPT-4 wins here, but it's almost a wash. On the common sense reasoning, why not Grande? GPT-4 scores 87.5 and PaLM 2 on the right scores 90.9. Here, PaLM 2 wins. Then on the GSM 8K, GPT-4 scores 92 using 5 shot and chain of thought. PaLM 2 scores 92.2 using chain of thought and self-consistency. And finally, we have the test that very large language models have a problem doing. It's called the Big Bench Hard. Here we have the result for PaLM 2 and it scores 78.1, but the GPT-4 test could not be done because they have included the benchmark data in their training set. So as a conclusion, we can say GPT-4 is clearly better than PaLM 2. But on the other hand, PaLM 2 is a much smaller model and is very competitive with GPT-4. Given the scaling that they were shooting for, they also had to find out if the chinchilla law scaling was still optimal for their dataset and their architectural decisions. They made these experiments using similar models but not the final model. Here you can see that for fixed compute, varying the parameters, they took the minimum point on the curve and plotted those. Here you can see the compute against optimal parameters on the left side and the compute against optimal tokens on the right side. And this is a straight line on a log-log plot, clearly showing that there is a fixed relationship between compute and optimal parameters. So the chinchilla laws still hold. They also investigated where to get the optimal performance regarding architecture, the data quality, and the training objectives. And this UL2 unified language learning paradigms featured prominently in the technical report. This is a paper that was written in February of 2023. Here is why this research is very important for PaLM 2. In the paper, they studied the effects of architecture on the performance on fine-tuned discriminative tasks and prompt-based one-shot open-ended text generation tasks. The prompt-based generation is represented on the x-axis, while the fine-tuned task performance is on the y-axis. All the models are compute matched. In this study, the GPT-like models performed just so-so. The ULT design for the decoder-only model was significantly better, showing about 66% on the fine-tuned task, and on the one-shot generation, having something between 6.5 and 7 maybe. We can see here too that the T5 model, which is an encoder-decoder architecture model, does extremely well on the fine-tuned task score, but is mediocre on the one-shot generation score. It's almost 4. The encoder-decoder version of UL2 performs spectacularly on both fine-tuned and the one-shot open-ended text generation. Apart from the architecture, there are other considerations in the training which we'll look at in a short while. In short, for the fine-tuned task, we can say that the decoder models are not as good as the encoder-decoder models. For the open-ended text generation part, it's less clear, but the encoder-decoder models show some middle to excellent performance. The decoder models have both the not so good performance and respectable performance. Looked at this way, then UL2 design was able to match these two objectives perfectly. Next, we want to briefly look at the data, and in this we have 3 separate issues to consider. First is the diverse data, which is as much data in many separate fields as possible. That's documents, books, code, maths, academic papers, and conversational data. Then you have the language part of it, where PaLM data from hundreds of languages was used to train PaLM2. And then there's the pre-processing of the data, cleaning out documents that have been computer generated, removing documents that have no information, deduplicating and removing even personal. If all these processes were done too, then we have the pre-training objectives that were used to make UL2 perform so well and much better than the decoder models for their size. In the UL2 research, they developed these 3 pre-training objectives that they showed were able to work well with a lot of the downstream tasks, like we've seen in this graph right here. The 3 pre-training objectives are called mixture of deionizers. These are the regular deionizer shown on the left of figure 3. Here, random tokens are masked out, and the training is to generate this masked token. Next on the right is S-deionizer, which is the masking of a span of tokens. And the training objective then is to generate the masked part, here labeled 95. For the R-deionizer and S-deionizer, usually the masked tokens are never more than 33% of all the tokens. On the right side of figure 3, we have 2 X-deionizer examples. The first one has a span masking, so you have 4 different spans, and these are generated as a pre-training. Next, you have many single tokens that are masked out. For example, token labeled 4 is masked out in 5 different places. The pre-training objective then becomes generating this masked token. By training with this variety of objectives, they were able to get this performance of the UL2 to be this effective, as you can see in the figure 1 above. They were also able to use self-consistency. Table 7 here shows the effect. As you can see, Flan PaLM2 had a GSM 8K mark of 92.2 with self-consistency. Without it, the score was 84.7 only. The effect of self-consistency was shown in this paper, and given how simple it is, it's surprising how effective it is. Essentially, you only have to do multiple generations for a certain query, and they were able to show consistently that self-consistency beat even imperfect chain of thought. You can see this in table 8, and in figure 5 shown here, you can see that self-consistency is correlated with the model's accuracy, and the research also showed that you can control toxic generation. Here's the research that shows this. The blue line is when no control token, and the orange line is when you have low toxicity and you have the control token enabled. The probability of toxic generation is low. For medium and high toxicity prompts, it's not as effective. So PaLM2 is extremely resource efficient. They said it's much smaller than PaLM, and PaLM is 540 billion parameters. I suppose it's less than 100 billion. They trained a lot more training than they trained for the PaLM 540 billion parameter. I'm supposing that given that the model is smaller, they probably used distillation to get more reasoning from the bigger model to train it. And the new Gemini model, which is probably much larger, might also be a candidate to use to train future PaLM. Okay, let's show off some of the PaLM 2's abilities. Here's code debugging and comments in Korean. Here is PaLM 2 scores on bubble code. As you can see, it's much better than PaLM Coder, a much larger model. And for poetry, here is an explanation of a poem in Persian. Then the equivalent poem, or rather proverb, written in Russian, and then a similar proverb in Arabic. And finally, a similar proverb. This is just magnificent. And yes, of course, it was able to ace the language exams. These are professional language exams, and in Japanese it's called 94%, and it's scored 89% in French and 87% in Italian. The worst score was Spanish, where it scored 67%. It attained a pass mark in all the professional language exams. So as you've seen, PaLM 2 is really a force to reckon with going forward. It powers more and more of Google AI, and we're looking forward to Gemini, to Gecko on the phone, to personalize models in Gmail, Docs, and Drive. And I think the future looks bright. Thank you.